Hi, this is James Mancini, and I'm the CTO at Netreo. And we're going to be going through today some of the ways you can reduce monitoring noise in your environment. So let's face it, network management is a drag. We kind of consider it our mission to reduce this effect, to actually fix these problems and make network management something that's actually easy and accessible and scalable up to even the largest enterprises without having to have a huge dedicated staff for that purpose. So some of the more common pain points that we hear from our customers when they're looking to implement a new network management solution is that they don't get a single view, they get too much alerting from their existing systems, and the admin overhead is really, really high. Today, we're specifically going to look at over alerting and how to fix that problem and really kind of talk about how we address what probably is the most common and the most painful thing about network management systems in general. So first, let's look at the problem. So one of the main things that we hear from customers is they're just getting too many notifications. Their inbox, their phone, their Slack is just exploding with notifications. And as a result, they're spending all of their time fighting fires instead of being able to prevent them. And it's great to be able to, find out when something's broken and rush out to fix it. Most network management systems can do that. Our goal is to try to get our customers into a position where they're actually able to proactively fix problems and actually deal with things before they happen so that they're not constantly in this firefighting mode. The third big complaint that we hear is about failure to notify, about systems that just simply miss issues, that don't find problems that exist in the environment. We're going to look at the cause of all of these next. So one of the main things about over notification. So we kind of find that there's a few common causes of this, and we're going to talk about how we address each of them in turn. One of the big ones is a lack of a defined notification plan. So if you're getting tons of alerts on absolutely everything because everything is switched on and you're monitoring everything, you kind of got an over-configured monitoring and alerting system. And it generally pays to make sure that we have a decent filter to make sure that we're not getting too many of those. So one of the things that we like to say about monitoring in general is if you're not going to take action, you really shouldn't be alerting at all. So we want to limit the types of outbound notifications that we send specifically to the sorts of things that you can take action on, and that you can get, a notification on that's going to cause you immediately to do something about it, as opposed to something that's informational or something that you're going to get in your email box and then not do anything about. So the second major issue that we hear from customers is about fighting fires instead of preventing them. So this is actually usually based on the fact that their alarming is set up only reactively. And it also generally means that they don't have a lot of automation in those environments. And automation is another great way to be able to start to try and get more proactive about, monitoring your environment and fixing the problems before they actually happen. Another really common problem with firefighting environments is that all the alerts are set up statically. There's no intelligence built into the system to detect unusual behavior or to find things that are not normally a problem but might be acting weird today. And as a result, you end up with a lack of reporting. There's no long-term visibility. There's no logs of what's going on. And you're kind of just constantly rushing around from one fire to the next to try to fix those problems. And the third big one is failure to notify. So the first question we usually ask when customers have a failure to notify in their environment, or their systems aren't just catching the problems, or they're unable to identify what's going on, is we look for monitoring policy to see if they know what they should be watching about the systems that they have. This is often driven by a lack of communication between development and production, where you can end up in an environment where the developers are rolling out new applications but aren't necessarily telling the production folks what or how to watch those applications to make sure that they're functioning correctly, or just not keeping up with configuration changes in the environment. If there's an environment that it's under constant change, you might need to do something to make sure that your monitoring system stays in sync with that environment, so that as people commission or decommission different problems or different devices in the environment, that they don't cause issues and they don't, they're able to identify problems with those new devices as they're created. So the first step in getting all of this under control is to create a monitoring policy. And the monitoring policy is really designed to lay the groundwork for your configuration. So this is a kind of common theme we see with customers when they're first implementing a network management solution or when they're replacing a network management solution is they don't really have a clear policy on who's supposed to be getting alerted on for what kinds of issues, and what are the different priorities, what are the high priority systems, what are the low priority systems, how should those be handled. And without that definition, it becomes really, really difficult to implement a monitoring system successfully because you never really know when you're done. So part of creating a monitoring policy is defining that action and escalation plan. What should people do when they get notifications? How should they be acting on those notifications? And what happens if they don't? Is there an escalation plan? Who do these notifications go to after the fact? Larger organizations often have some of this in place, but it often doesn't directly address the configuration of how we're monitoring things. So how often do you monitor services, or how often do you, check to see if that website is functional? And when it isn't, who do you notify? How long does it have to be down before you escalate those notifications, et cetera? And another key point with monitoring policies is that you really have to schedule a time to update the plan. The only way to keep a monitoring policy in sync with your organization is to just put it on the schedule so that once or twice a year you're going through and you're reviewing how the monitoring policy is working. You're looking at incidents that happened and if they were over notified or under notified, or if they escalated properly or didn't escalate properly, or if the operations folks didn't handle the issue properly, they didn't acknowledge the problem, they didn't work the problem through the existing ticketing or change control systems, and make changes to the plan to adapt it to your environment so that it better fits your business objectives. And you can really make sure that the goals of the business are to deliver these services to their employees or to their customers, and that the monitoring policy is serving those goals. So it's really an important step to update the plan on a regular basis and evaluate how it's really doing in the environment. So one of the models that we use to help customers come up with a prioritization system is a really simple grid where we take the severity of the impact of a problem and we plot it against the number of users that are impacted. And this kind of gives you a grid that you can then divide into different priority levels. So a real common way to do that is to say, anything that's a severe impact or impacting a large number of users is priority 1. If it's, impacting less users or less severely, it's a priority 2. And then if it's impacting fewer users or not so severely, or there's workarounds, it's a priority 3. The key to this process is figuring out exactly how to make sure that issues are handled in a timely fashion, but that you're not sending just a stream of endless alerts to all of the people, because that just won't work. If you've got, a large number of operations folks that are receiving these alerts, or engineers that are receiving these alerts, too much alerting is almost as bad as no alerting at all, because people will just filter it out. They'll block it, they'll send it to an alternate mailbox that they don't really watch, or they'll just get messages and ignore them because they know that 9 times out of 10 it's not something they have to deal with right now, and that makes them miss that 1 time out of 10 that it really is critical to deal with the particular issue at hand. So one of the things that we use as kind of a shorthand for this is if everything is critical, nothing is critical. So the idea is we have to really define what are those priority 1 incidents and how do we want to handle those? How fast do those escalate to the next level of engineer or the next level of management? How long do they have to be down before we react to that problem? And with priority 1, we want to make sure that's as short as possible. But we might have priority 3, or you might even have other priorities. You could have a priority 4 and a priority 5 for development or test systems where you really don't need to react to those specifically, but you might want to be aware of them. So you want to build your monitoring plan around the idea that each of these different priorities is going to have a different set of escalation steps and different timers associated with them. Maybe a priority 3 system can be down for a day before it escalates to management, and a priority 1 system can be down 5 minutes. It just really depends on your environment. Some customers will actually need more priority levels than this, and some will need fewer. Some may need much more complicated models to define priority levels. You may have critical systems that are priority 1, but they're part of a big cluster of systems. So if only 2 of them are down, it's not really a big deal yet because the actual application is up. And all these things need to kind of be tailored into your environment and into your monitoring plan so that you can make sure that the monitoring system that you're using is configured appropriately and stays configured to meet your business objectives. So one of the next steps in a monitoring plan is to make an action plan. And the more specific your action plan is, the better off you're going to be. So if you can define exactly what people are supposed to do when they get a certain particular type of alert, you can almost build a run book that says, hey, if you get alert number X, you need to perform steps 1, 2, and 3. Very few organizations are going to go through the amount of work that it requires to get that granular with, at least for most of the systems that they're monitoring. They may do it for a few mission critical ones. But the more specific you can manage to get your plan, the better off you're going to be. But in a minimum, you should define who, when, and how to notify people based on the priority of that system. So, your priority 1 database servers are going to go to a specific group of people. They're going to get notified at a specific interval. It's going to escalate to management after a certain amount of time. And you have to figure out what those escalations are and who they should be going to and what methods they should be going to. You should also be thinking about in this plan time of day and day of week changes. If you don't run a 24/7 operations shop, what happens if a system goes down after hours, and how is that affected by the priority of the system? So, a priority 3 system going down after hours might result in an email going out to the group, but nobody really gets paged for it. A priority 1 system might wake everybody up. But you need to factor that into your plan and make sure that it's addressed so that you can make sure it's configured properly. Also, you should be asking yourself, what can you automate? Are there ways to take some of the functionality that you need operators to perform and to automate them? Things like restarting services or servers, or automatically rebooting switch ports and things like that, that are routine tasks that you can automate as part of the action plan, and then using the tools that you have, automating those processes to reduce the administrative burden required to run them. So one of the number 1 questions we get asked is how to reduce the alert volume. Once you've got your monitoring plan and you kind of know how you want things to be alerted, the next step is to figure out how to actually reduce the amount of alerts that you're getting. And the first and most important step is to use the functionality built into your tools to do things like root cause detection. OmniCenter builds in the ability to automatically detect parenting and topology so that, for example, if a remote router goes down, you don't have to get alarmed for all the switches and servers that are behind that remote router. You can just get alarmed and say the remote router is the problem, and all the other problems are grouped together in a single incident. That's our approach to that particular problem. And it works well to reduce the volume of alerts that you're getting. With OmniCenter 11 now, we both have layer 2 and layer 3 topology mapping automatic, but you can also manually set your parenting and topology. It's an important step in making sure that you limit the number of devices you alarm on, because you really don't want to be alerting on things that are totally unreachable. If they're not accessible in the environment, you don't really need to get notified about them. You want to know what the root cause of that unreachability is and address that problem first. You should also, if you decide not to do this kind of alert consolidation, consider the impact of a mass outage. So if I really do have a main router go down that's connecting hundreds of remote locations, how many alerts is that going to generate if I'm not doing this kind of consolidation? And can my mail system handle it? Can my bones handle it? How do my engineers react when they get 200 alerts at the same time? It really can cause serious problems with how the problems gets addressed and increase the time it takes to repair those problems. As I said earlier, one of our big bellwethers that we use for reducing alert volume is to only alert on things that you're going to take immediate actions on. So this means if you've got problems in the environment or issues that are going on that aren't impacting immediate user performance. They're not causing connectivity problems, they're not causing performance problems, but they might be things that need to be addressed. Actions might not be the right way to deal with them. If you're going to get an immediate notification on something, you want that to be a notification that means the engineer who gets it is going to drop what he's doing and fix that problem. Everything else can be relegated to reports. So the classic example of this is, it's great that the system can tell you when a hard drive gets to 95% and you need to rush everything and run to the server and delete all the log files to avoid creating a problem and having the server crash. But it would be a whole lot nicer if I could just know that when I came in the mornings, I had a report waiting for me that said, here's the servers with the lowest free hard drive space. So I can go in and address those before they even get to the level where I have to send out a notification because there's an immediate problem pending. So you actually have a little bit of both, but if you're addressing those problems proactively by getting those reports, you're really getting ahead of that firefighting process and fixing the problems before they impact users. A key point to making this work is to make sure that the reports are automated. If you're relying on people to run the reports and send them to you, there's almost no way it's going to work. You might get 95% compliance, but it's just Murphy's Law that the one day that guy forgets to run a report or he's on vacation, something's going to tip over. So Automation and scheduling of the reports is a key point in that process. And what OmniCenter does to make that easy is almost all of the reports that you can get through the web interface, with a single click, I can make that report what we call a custom report template that can then be sent out via email, daily, weekly, or monthly to any number of recipients. So we try to take it so that almost any of the different views that you can get to in the tool and all of the different reports can instantly and easily be automated. And we do that specifically because if the reports automation process requires someone to go in and who's familiar with Crystal Reports or SQL to write your report language, it's probably going to take too long to be implemented in a practical fashion, or it's never going to stay up to date with what the needs of the business are. So if you're spending a lot of admin overhead kind of creating and managing those reports, it's less likely to be a successful strategy than if you can just automate anything through the web interface and it doesn't require any special training. That's kind of our approach to that particular problem. Let's take a look real quick at what an actionable alert actually is. So one of the key things that we want to talk about is what kinds of alert am I going to take immediate action on? So let's say I get an alert that says the server's average CPU is greater than 90%. Is that something I'm going to take immediate action on? Generally, the answer to this question is a maybe. It depends on your environment. In most environments, the answer is no, because a server running at 90% might be normal for that particular time of day or that particular day of the week. And if your operators don't get that information as part of the alerts, or aren't being properly informed as to what actions they're supposed to take, they may go to the system and see what processes are running and, oh, look, lo and behold, it's SQL, it's taking up 90% of the CPU, but I don't really know how that's affecting my application from that piece of data alone. So this is an example of something that I would say in most environments should not be an actionable alert, because you're dealing with a situation that may require user intervention, but more likely is normal for that time of day and day of week. OmniCenter allows you to use anomaly thresholds to detect unusual behavior so that you can get notified about things that are out of the ordinary while suppressing alerts for things that are routine. And again, you can always get a report set up at the end of the day or at the end of the week that shows you what the CPU was across those devices, and all the way down to the per process level with OmniCenter show what processes were taking up those CPUs, so that you can determine whether or not it needs to be addressed that way. Things that are happening at a higher level or application layer might be the critical alert that goes out there rather than just the average CPU threshold. Something like a critical switch port down obviously should be an immediate alert if your engineers are going to immediately deal with it. We actually have seen environments where they have ether channels set up with so many different ports in them that a single switch port down might not be something that they're going to take immediate action on. It's something they're going to address after hours when they can go in without a risk of impacting production. But if it happens to more than one switch port in the same trunk, then they need to go and deal with it right away. So you need the flexibility to control how those alerts are sent out and what the monitoring system considers to be a problem in order to make sure that the alerts that you're getting sent out are ones that they need to act on. Public website offline. This one's pretty unambiguously something that you're going to want to take immediate action on. And again, the higher up in the chain that you're monitoring, if you're monitoring things at the application layer, like OmniCenter does with its web application monitoring, then yeah, you want those to be immediate alerts, because that means all the underlying systems may be down or all of the dependent systems may be down. And that's something that you're going to want to address very quickly. So generally speaking, the higher up the ISO model you're monitoring, the more urgent that alert's going to be when it actually does happen, because the more likely it is to be impacting users directly. Now, one of the other things that we talk about as a great way to reduce alert volume is to automate. So automating alerts allows me to do things like automatically restart servers or services or ports or issue commands on those devices. And I can do that either reactively. So as soon as OmniCenter sees a problem, it can SSH or run a PowerShell against that device to execute a specific command or series of commands that you've told it to do. Or if you want a little bit more control, you can also tell OmniCenter to only execute those commands manually based on the permissions of the user that wants to execute them. So one example of this is, I might set it so that a NOC engineer can go in and try to do a restart on my web server service. But if the whole server needs to reboot it, I want somebody with more privileges to be able to do that, an admin or a power user to be able to go in and issue the full server restart because they know it hasn't been tried, or they know that the previous attempts to fix the problem haven't been successful. So OmniCenter gives you the flexibility to do those either fully automatically or to have manual intervention if you want more control. One of the key points to automation that a lot of people don't remember, however, is maintenance windows, planned outages. So we had a customer many years ago who implemented an automatic service restart for one of their key Windows systems. And all of the critical systems would automatically restart as soon as we detected an outage. And this worked great right up until the time they tried to do their first planned upgrade and forgot to create a maintenance window, because every time they logged into the server and stopped the service, they would go in, stop the service. As soon as they went to go load the program would, the update would fail because it would say the service was still running. And it actually took them a little while to realize that the problem was OmniCenter was detecting that service down and restarting it before they could get the update fully installed. So if you're going to be using full automation, you have to remember that part of the process is making sure that planned outages are integrated into your OmniCenter system. And in OmniCenter now, you can actually issue maintenance windows by grouping, so by site or by category or by strategic group, in order to ensure that all of the systems that are being affected by a known outage are kept up to date with those maintenance windows. And there's also a good API for creating and removing maintenance windows as needed if you want to integrate that into your other processes. One of the other keys to reducing the alert volume is to correlate the problems into a single notification. And a couple of examples of this that I like to give are what I call an application cascade failure. So the question then becomes, if I've got a web application that runs on a web front end that's several different systems, and they all talk to a middleware system that then talks to a backend database. If I'm monitoring each of those individual systems, I might want to consider if the database is down, and that means that the web application isn't functioning. Who should I notify about that problem? Obviously, the database group needs to know about it. Should the application group know too? Can I consolidate that alert for the database group and basically suppress the alerts at the application layer? Because I know if the database is down, then the application isn't working, and I can consolidate that into a single message that says, hey, the problem is the database is down, instead of sending multiple messages for, hey, your web server is down, hey, your web server isn't responding, the website's not up, the database is also down. Rather than showing all of those different failures as separate alerts, I might consider being able to correlate those all into a single alert for a cascade type failure like that. You can also consider this with things like infrastructure dependencies. So latency is a good example of this. If I have a remote site that has very limited bandwidth and I start to get latency alarms from one of the devices at that site, maybe all of the other devices at that site are going to generate latency alarms too. I really don't need to get those. I need to be able to make a rule that says when you get multiple latency alarms from the same site, please consolidate them all into a single notification. So I get one message that goes out to everybody that needs to know about the latency problem. Or maybe I have that based on, if I have a bandwidth alert, don't send any latency alarms for that same location, because I know it's going to be based on the fact that there's limited bandwidth at that site. And if they're at 90% utilization, everybody's latency is going to start to suffer. So those kind of dependency alerts can be a great thing to roll up to further reduce the amount of notifications coming out of the system. Another one of the real keys is to stay on top of the process itself. So if you acknowledge alerts as they're handled, if users are taking ownership of the incidents and acknowledging them through the system, whether that's through your trouble ticketing system and integrating, or directly in the monitoring system with OmniCenter or via a mobile app, for example, like we use, that allows the system to stop bugging people. So acknowledgements will generally stop additional re-notifications, they'll stop escalations, and generally cut the volume of notifications coming out of the system by a great amount. One of the main things that we look at when customers come to us and say we've got too many messages coming out of the system, the first thing we check to see is if they've got a process whereby they're acknowledging the problems, or if a lot of the messages they're getting are re-notifications on problems they've dealt with, but their operators don't know how to acknowledge the problems, or there's no integration with their ticketing system, so it's not automatically acknowledging the problems via an API like we do in OmniCenter. Another key here is to use the maintenance windows for the planned outages, whether it's done via the API or whether it's created via the web interface. It's critical to make sure that when you do have a planned outage, that you put a maintenance window in place to suppress any of those notifications that might otherwise go out. And also, make sure that you're integrating your monitoring system with your existing processes. So if you've got ticketing systems or change control processes, wherever possible, make sure that those are all linked together. So it's very easy to, for example, if you've got an online change control system, have it send a message directly to OmniCenter to create maintenance windows when a particular change is approved for those devices. All of the APIs are there to do that. And the further you can integrate that process together, the more likely you are to not have issues with the excessive alerts. A couple of best practice tips. Using distribution lists for all of the email alerts and reports is also a great way to manage your alerts. And this is for two main reasons. One is it's much easier to keep in sync with personnel changes. So it doesn't become a separate point of administration where you have to remember to go into your monitoring system and authorize specific users and deauthorize them if they leave or if they go on vacation. It kind of gives you one place to manage all of that. It also allows you to create an archive for historical reports. So depending on your email system, I might be able to create a mailing group that every time a report goes out to my network engineering group, it gets copied to a mailing list that gets archived on Google Groups or in Office 365 in a shared folder so that I can go back and look at all of those historical reports if I ever need to. You can also tune your alert volume by using the reports that are built into the monitoring system to identify what we call the noisy birds. Who's the ones making the most alerts for a given type of notification? So if you've got reports that will allow you to find where all the notifications are coming from and which specific devices or service checks or thresholds are generating them, it gives you a way to go in and find out where those messages are coming from and then to tune them to make sure that false alarms are minimized. If there's a threshold that's set too tightly, and so it's constantly popping in and out of a critical state and generating a lot of notifications, these kind of reports allow you to find and locate and fix those problems really, really quickly and easily. And in OmniCenter, there's a template baseline report that's in OmniCenter 11 that allows you to look at all of the devices that are set to a particular template and see which ones are generating alarms, what kinds of alarms they're generating based on, is it a threshold setting, is it a service check setting, and tune those specifically to reduce the amount of alert volume that you're receiving. We also have something called the notification summary reports. This reports in all of the OmniCenter versions for the last several years, and this allows you to go in and identify, for example, is it latency alarms? Is it a specific group of devices that are generating it? Summary reports allow you to group that data by device or by service check or by threshold type, so you can identify kind of where the most of the notifications are coming from. And what we find is in a lot of environments where they don't have a monitoring policy and they haven't really been keeping up on the configuration, these summary reports are a great way to identify places where the configuration needs to be modified and tuned up, and to really reduce the amount of alerts they're getting as a result. So the kind of tangent to reducing the alerts themselves is to kind of manage the methods and ways that notifications go out. So if we consider how we get notifications through the environment, the traditional ways are things like email, SMS, or through mobile push technology, and these are obviously, very common. They're appropriate for things where you need an immediate notification. Especially mobile push is useful because it can be completely independent of the local email infrastructures, and because it rides on web APIs, tends to ride through firewalls without as much configuration. So mobile push is a great alternative to traditional SMS notifications or to email notifications. But you may find that for certain types of issues or certain priorities of issues, different notification methods are appropriate. It might be appropriate to notify management about a major application outage via email as soon as it happens, but then escalate later only via SMS or mobile push if something really goes wrong, like it hasn't gotten fixed within a particular amount of time. So just when you're creating your notification plan, you need to be thinking about the notifications in these ways and kind of what technologies are used to get there, and make sure, like, if I'm entirely dependent on email notifications, I need to make sure my email infrastructure is very robust, or I have alternate paths to email infrastructure, like I'm emailing an outside mail address. So if my mail server goes down, I'm not blind, I don't lose those kinds of notifications. And we highly recommend that you have at least two, if not all three of these methods configured for notifications. But some of the newer technologies that have come out, things like Slack and Spark and other kinds of group communication protocols, might factor into your notification plan. So if your organization is using these kinds of group notifications or group communication systems, having all the developers just kind of passively notified via a Slack notification when a major application is experiencing a performance problem, gives them a way to kind of keep their finger on the pulse of what's going on without necessarily waking up in the middle of the night or, being bugged to go fix something in the middle of their production day when it's not a critical problem. So you want to look at these other technologies and maybe figure out how those might be appropriate ways to, further leverage notifications in your environment and really integrate with the processes that you're using. But you always also should remember that priority is a key here. So for high priority systems, you're going to want to have much faster notifications than for lower priority systems. And really having a clear picture in your head or in your monitoring plan of which systems meet the credentials for high priority versus low priority are all kind of key points that you want to keep in mind. One of the other best ways to manage notifications and keep the alert volume down is to centralize the alerting if possible, because this avoids a lot of duplicate notifications. It can avoid conflicting status reports if you have multiple systems monitoring and one of them sees it down, but the others don't see it down. You can run into a lot of problems with having different groups arguing over whose problem it is. Is it a database problem? Is it a network problem? Because they all have different tools and all the tools are telling them different things. It also gives you a single point of acknowledgement and communication. So if somebody in the operations group has a networking issue and manages to acknowledge that problem, that can be seen by everyone else in all the other groups so that they know operations is already working on it. And that can actually reduce help desk communications. It can, reduce communications from end users, even if you've integrated that kind of status information into things like your company intranet. Communicating that status back and forth with a single place to look for it makes a big difference in terms of effectiveness across the organization and the efficiency by which you're using your staff and your resources. The larger an organization you are, the more this becomes an issue, because obviously you need to manage more and more systems with few people. You can't just scale the staff indefinitely. So at some point, you need to be trying to make the people you have as efficient as possible and reducing the volume of alerts and focusing their attention on the real problems. And also giving them a single point of communication between all of them becomes a big factor in that. It also, as I said, gives you one place for status between teams so that you don't get into a situation where the database folks are pointing at the network folks and everybody says their systems are okay. Having a single point of alerting and communication makes that process a lot smoother. You should also look to, wherever possible, integrate with your existing systems via APIs. So this can be things like notification managers. If you're already using notification managers to handle things like pager rotations or on-call hours, look for a way to integrate via an API with those systems. OmniCenter has all of the hooks needed to integrate with all of those systems. But whatever system that you decide to go with, look to make sure that it's got APIs. And if possible, you might even be able to establish two-way communication between it. So if someone acknowledges a problem through OpsGenie, that can come in through an API and acknowledge the problem in OmniCenter. Or the same thing is true of ticketing systems. If you're using things like ServiceNow or Remedy to manage your actual tickets, you should consider doing a deep integration in that regard so that you actually have your system opening up trouble tickets, when it detects problems, when people take ownership of those problems, it could acknowledge those automatically via two-way communications via that API, and even automatically closing issues once the monitoring system sees them resolved if you want to. All of that is going to be highly dependent on what your actual workflow for problem solving is, and that's going to tie into that monitoring plan that we talked about originally. The next major aspect of managing a monitoring system and reducing that noise that comes from it is to manage the configuration. And the key point to managing a configuration is to simply not rely on manual processes. If it requires someone to go in and manually go in and configure a system every time you add one or every time you remove one from the system, it's almost impossible in a big environment to keep that up to date. So one of the keys is that you should really be trying to automate those administrative processes wherever possible. One of the key ways to do that is AutoDiscovery, but it shouldn't be limited only to scanning. AutoDiscovery should be integrated with all of your systems wherever possible, using deep links into the APIs, whether that's configuration management tools or whether that's things like deployment tools like vCenter. Those deep links into the APIs will go a long way into making sure that your monitoring system stays plugged into your environment and is up to date with all of the right systems being monitored and none of the wrong ones. The key way to do that is to link the monitoring into the provision process. So you can do that via a number of different types of APIs. Some of them are inbound and some of them are outbound in OmniCenter's case. So you can integrate with things like Puppet and Chef. So when you deploy systems, you can have automatically added into OmniCenter monitoring, or we can have us monitoring the APIs for things like vCenter and Hyper-V and hyperconverged systems, so that as new systems are deployed in those environments, we're automatically able to add them into OmniCenter and then get them configured correctly in monitoring. The same thing is true of cloud resources and systems. Most environments now are beginning to go to at least a hybrid model where some of the resources are being moved out into the cloud. So having links into the major cloud providers to be able to automatically detect when new systems are provisioned there and then add them into monitoring in an intelligent way so that all the settings are predefined is kind of a key point. So another big point in configuration management is the use of anomaly-based thresholds. So the whole idea behind anomaly-based thresholds is that we can detect and alert on unusual behaviors. So the idea is that instead of just saying CPU over 90% for 15 minutes is a problem, we can certainly do that. With an anomaly-based system, you're also asking the question of, what about at this time of day on this day of week over the last 8 weeks? Is this higher or lower than is usual for this particular time of day? So you can detect unusual behavior that might indicate a problem forming or might indicate a problem that isn't yet reached the point where it's flagging a static alarm. So maybe the CPU is only at 65%, but for this time of day on this day of the week, it's normally at 20%. That might indicate that you've got a problem forming or that something unusual is going on that you need to look into. And if you're trying to manually tune thresholds to do this, it just becomes too much admin overhead. So you really need a system that can do this based on anomalies and can automatically generate those baselines to detect when a problem happens. Now, with anomalies, you also have to have the ability to define what is an anomaly, what is too sensitive, what is not sensitive enough, and really adjust the sensitivity of those anomaly thresholds so as not to create excessive alerts, because that sort of defeats the whole purpose, that we're talking about, trying to reduce that over alerting. So adjusting the sensitivity, and again, going back and reviewing periodically using those alert reports to find out what got notified, find out what anomalies were detected, and to tune those that sensitivity where needed is a really important function for anomaly-based threshold monitoring. Part of automating the process of administering a network management system, though, is that you really have to have a configuration that's based on templates so that all of the alerts, thresholds, service monitors, application monitors can all be kind of pre-configured for your systems as you go, and that you can create those templates and tie them in by priority, by application, by what platform they're running on. And the templates should also fully define all of the different actions, escalation, and automation functions that you want to integrate into your system. OmniCenter gives you the tools to be able to do that very easily, and you want to be able to make sure that when I define a template for a priority one database server, I've got all of the right settings in there, because then I can further automate that process by using rule-based automation to apply those templates. So the real key to making this a zero admin process when I add in new systems is whenever we detect a new system, whether it's via an API and a new system spins up in AWS or in vCenter, or a network scan detects a new network system on board, you really want to be able to have a rule that allows the system to define what templates should be applied to that system. So all the monitoring, alerting, escalation, automation, all those functions just immediately apply to it and doesn't require a manual intervention. If I do this, if I set those rules up, I can make sure that I've never missed a configuration. So I can avoid that whole, didn't get alerted on a particular problem because somebody forgot to apply the, SQL database check to this particular server. I can make sure that the rule says anytime you see a system running SQL on it, add this particular SQL check, via this template, and then I never miss that step. And they can automatically be applied to all of the devices that we discover, regardless of what method they get added to OmniCenter, whether it's APIs, whether it's scanning, whether it's integration with, a deployment system like Puppet. All of those rules will automatically be applied to those systems, so I can make sure that they're always tuned just right for my environment. You can also reapply those rules as desired. So if you want to use that to enforce compliance and make sure that all of your systems remain compliant and are set the same way all the time, I can be reapplying those rules on a regular basis so that no one can change my settings accidentally and make me miss an alarm or make me misconfigure a particular setting in the system. Thank you very much for attending. I'll hope you join us for a future webinar, and we'll be running a series of these over the next several months. If you have input as to what kind of topics you'd like to see in those webinars, please fill out the survey that you'll receive after the webinar is over here, and I look forward to hearing from you all. Thanks very much and have a great day.